This is less than 79, number 28. So we have to find the distance between these two things. So I'm going to put it in y equals mx plus b is my favorite way. So and then I can say divide by -3. I got y equals, this feels familiar, like I've done this problem or something. I did one kind of like it, I think, yesterday. Did I do it right with the, okay, good. So that's a line, and this is a point, and you know me, I can't resist drawing something, so I'm going to draw this. 1, 1, 2, 3. So there's a point, 1, 3, and then here this thing, what's 5/3 anyway? 5/3 is about 1.6. So there's 1 and there's 2, so something like that, and then it goes up 1/3. Up 1/1, 2, 3. Something like that. Just so we have a picture to look at. So there, we'll call that the blue line. So there's a line, so I want to know how far, I want to get a perpendicular line. We'll call it the black line. You can't see the difference of the colors, but we'll call it the black line. And that little bitty distance right there, that's what they want. So the black line has a slope of -3 because we have to do the opposite reciprocal. So we're going to have y equals -3x plus b. We don't really know what b is. Some big number, huh? We don't know what b is. So we'll plug in 1, 3 is going to be on our black line. So we'll go 1, 3. So that's, if I add 3 to both sides, it's just, well, that doesn't look very, my slant isn't very nice on that, because that looks like way higher than 6. Okay, so we have our new line is, the black line is y equals -3x plus 6. Now I want to find out what that point is where they cross. So I do a system of equations on these two lines. So I can go 1/3 x plus 5/3 is equal to -3x plus 6. The reason I'm allowed to do that is it's kind of like I substituted y. Yeah, now I'm going to multiply by 3 because I just don't, those fractions are just making me want to throw up. So if I multiply by 3, I got x plus 5 equals -9. X, what's 3? 18. And then I could just add 9 to both sides, and I would have 10, subtract 5 from that. Ew. So it's always, yeah, a lovely little fraction, it seems like. That's 1.3-ish, or third. What if I just said, well, I don't want to play the fraction game, I'll just do decimal game today. I don't know. I don't know if fraction or decimal, which one I like best. Let's make sure we're on the right track. Yep, okay, we're on the right track. So then you want to plug back in. So I can go -3 times 1.3 plus 6 will give me y. So 3 times 1.3. I sound so excited about this, huh? I got 21/10.
Yeah, 21/10 is correct. So it's 2.1.
So it's 2.1 if I want. I don't know if I think it's easier with the fractions or the decimals. So there's your x and y, and then your other x and y was the ordered pair, x is 1 and y is 3, and then so I know I can put those in my distance formula. So you find the difference of the x's, square it, find the difference of the y's, square it, and that's your distance. So the x's, I can just go 1 minus 1.3, 1 minus 1.3, all squared. and I'm gonna go square. I got 9, I got
So 3 root 2 over root, square over 3 root 2 over 5.
Yeah, so if you want it in radical form, it's 3 root 10 over 10, or you could just say it's 0.9486 blah 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 blah. And this is number 28. They left it as 3 root 10 over 10. So I should have probably called this 9/10, right? Let's just call it 9/10. And then you'd get, do you see how you'd get 3 over root 10? I changed my decimal, I changed my mind. Turned it into a fraction. It's the same thing, but so that would be root 9 is 3 over root 10, but then when you rationalize it,
It's gonna be 3 root 10 over 10.
yeah, it's 3 root 10. Is that okay? So I learned my lesson about turning them into, I never tried turning them into a decimal before, but I thought